Hey guys, it's Mr. Bowers. I'm here to talk to you guys a little bit about radioactive decay. What you should have out in front of you right now is a P table and also the sheet I gave you yesterday, which is called alpha, beta, gamma. If you do not have that sheet, that's okay. You can go to our haiku page and go ahead and print off a copy or use it as a Google Doc and just make it work. So again, have a P table out, have this sheet out. We're going to take a couple notes, we're going to do a couple example problems, and then you will be on your own for questions 1 through 7, and we can talk more about this the next time I see you. All right, so we're going to focus on what radiation is in general. So, and what radioactive particles are in general. So radioactive elements are unstable. If you remember the FET simulation we did the other day, you can make pretty much any atom unstable by adding a bunch of neutrons to it. Those neutrons that you add make your nuclei unstable. They kind of break apart, and that breaking apart, that's radiation. That's radioactive particles. That's energy. You know, energy is released when that happens. So all elements with more than 82 protons are radioactive. So if you look at a P table, atomic number 82 is lead. So anything with a number larger than 82, all those things are radioactive in all forms. Now, elements with numbers smaller than with less than 82 protons within them, you can also have radioactive isotopes. They just have an unstable amount of neutrons, and they want to break apart, they want to become stable, so they do. So this is a natural process. We're going to focus on two particles. We have helium particle, and so if you look at this, you think about this, this is pretty much just a helium nucleus, right? You have protons on the bottom, or that is your atomic number, which is the number of protons, and on the top, the bigger number, that's your mass number. Remember, that is the number of P's and N's together, protons plus neutrons together. This thing is called an alpha particle. All right, it is an alpha particle. The other particle we're going to deal with is a beta particle. A beta particle is simply an electron. That's it. Beta particle. And these electrons, really, they don't have a mass number or anything, right? And it's kind of unique what's happening with it. So I'll talk about these two numbers as we take some additional notes. The back side of this sheet is nice and blank, so we have plenty of room to write. Now, the other type of radiation is gamma radiation. Gamma radiation is just energy. And so anytime an alpha or beta breakdown happens, gamma radiation is also given off. It's just energy in the form of high energy, like, you know, radio waves are a type of invisible energy. Thermal energy is invisible. Gamma radiation, you cannot see it. It can be detected, but it's just high energy, very high energy. So we don't really need to denote that. It is not a particle or anything, but anytime decay happens, gamma radiation happens. So we're going to do two examples on the back. We're going to focus on uranium. So if you look at uranium on your P table, it has a mass, and we're going to kind of just format this based on here. So look at one of these blocks. the bigger number is always on top, smaller numbers on the bottom. So on top, it's your mass number. On the bottom, it's your atomic number. All right, we're just going to follow that format. So we're going to focus on uranium. We're going to look at uranium. We'll call it uranium-240. It could also be denoted as U-240. And so you look at your P table, that uranium, it doesn't really appear. You don't see 240, you see this 238. Remember, that's the average weighted mass. All right, so uranium, 92 goes on the bottom. That's the atomic number. 240 on top. This just happens to be a certain isotope of uranium. If it undergoes alpha decay, we must make an alpha particle. And an alpha particle is a helium, right? So what we're really focused on is when alpha and beta decay happens, new elements are created. All right, so what new element are we creating? So on the bottom here, remember, this is your atomic number. So if you are losing two protons, if you are losing 2 protons from uranium, your new atomic number isn't 92, it's 90. 90 plus 2 is 92. Your new mass number is not 240, it's 236. 236 plus 4 is 240. So remember that top number, that is your mass number. That's your P's plus N's. All right. So what new element did we make? Well, I have a P table right up here. We started with uranium, it's 92. We have turned into thorium. And so uranium will decay into thorium. It will continue to decay until it becomes stable. And that a lot of times that ends at lead. So eventually we shouldn't have any more radioactive material, because eventually they should all decay unless we create more. So that is alpha decay. Make sure you label this alpha decay. Remember, when this is happening, gamma radiation is also produced. So gamma rays are happening. You do not get superpowers from gamma radiation. The other type of decay I want to focus on is beta decay. And we'll keep the same element. All right, so we'll stick with uranium-240. So we got 240, 92. This is uranium. And we're going to look at beta decay. All right, so when beta decay happens, a beta particle is produced. A beta particle is an electron, but that electron comes from somewhere. This is kind of crazy. All right, we're trying to figure out what new element we are making. On the front of this, I had this kind of going on. All right, so that's kind of weird. So that means that the total number of particles is not going to change, because 240 plus 0 is 240. But this is weird, right? So 92 plus negative 1, like what? That's kind of weird. So what's happening in beta decay is a neutron. Here, let's use abbreviations. A neutron turns into a proton. So a neutron is turning into a proton. So we're actually going to add a proton. So within neutrons and protons, there are many, many particles. This type of decay just happens to be just that. So you're looking at atomic number 93, Neptunium, NP. And again, when this decay happens, gamma radiation is also given off. It's high energy radiation. In addition to that, this particle is flying around. In addition to that, new elements are made. All right, so on the flip side of this, you guys have 7 of these you can practice. I filled in a bunch of things, so just kind of use what I did in here as a model and see how you can do. We'll talk tomorrow. Email me if you have any questions.